Okay, thanks for being here. Just gonna get this started as well. So we're gonna talk. It's sort of mixed between technical and not so technical. How many of you are developers? Yeah, almost all of you. Okay, that's good. So we'll see if I can impress you, or if you're just gonna be slightly. I can do that. Let's start. If this is talking. Yes. So I'm going to talk a little bit about myself, not too much, because that's not the interesting bit here. As Björn said, we're from Softhouse, and we love to share knowledge. And I work as a security expert, design systems to be secure and so forth. So I deal a lot with this, because this is basically the default state today. We don't do that much security, but I have actually a secret agenda with all this, and that's I want to have more free time. So if I could teach you all and you will bring something with you back and you start doing things differently and doing more secure, then I can probably play TV games at home or something. I don't know. But let's see. So that's enough about me. We're going to talk about APIs today. This is the typical setup. You have some services running somewhere, Azure, Amazon, on-prem, wherever, and you have a few consumers, few devices out, anywhere in the world going to talk to your services and do these generally through endpoints in an API. And the thing is, you don't really know who's on this side. And one thing is that this is an access layer. It's not per default a security layer. It's about making them getting access to whatever's on this side. So default is full open access. And since you don't know who they could be practically anyone. And it could be that you actually do have stuff over here that are quite valuable. And in a default state, that's unprotected. And this is what we're going to try to talk about today. Is there any way of actually making this more secure? How do you do it, and what do you don't do, and so forth? So before I start, I'm just going to talk quickly about these companies here, and I think you recognize all of them. They have quite recently had breaches through their APIs in one way or another. And usually it's because they missed something, that there was a bug in the system, they did something wrong. But most commonly is access problem. They give more privileges that they shouldn't give through an endpoint. And Google here, a couple of months ago, they leaked 500,000 accounts from their Google Plus through an API call. And 500,000 isn't much. When we talk about leaks, you usually talk about millions and millions of users. There was only 500,000 here, but that's because it's Google Plus. It was probably all the users of Google Plus. So, yeah. But that is quite serious when this happens. So I'm going to start talking about these two. Authentication and authorization. So in here, how many of you could say you know exactly the difference between these two? I'm not going to ask you, so, you know. I'm just going to see, because these people tend to mix these up. This text here is from Wikipedia. I just stole it right off. And it's about authentication. I'm not going to have you read all this, and I'm not going to read it for you, so I just highlighted a few words. It's about confirming identity claim. That's authentication. So basically who you are, nothing else. It's not what you can do or what you're allowed to access, it's just who you are. And if we look at the other one, it says authorization, and again, a few words been highlighted here, specifying rules to decide access. I've been quite creative in selecting the words. So that's about what you can do. So there's nothing about who you are, it's only what you can do. So one of them will say, this is you, and another one will say, you can do this. So really, we need both of them for this to work. You can't have just one. And if you look at it, these are basically same as an identity and access rights. So they need to work together. So in kind of a login situation, it would be your user and what your user can do. If we take these two then, if I have the same question, more or less, who of you could implement these correctly if we were giving? You're going to design an API, so we're going to have access keys and we're going to have secrets. So anyone comfortable say, well, I can do this, that'll be fine. Swan, yeah. Again, I'm not going to check. Can do that afterwards. Can compare notes. So this is actually more or less the same as a username and password. I'm not entirely clear which one is which, but they're used like that. So looking at a solution with this, so you would have an API in the middle, you have services and consumers on one side, and you will give out access keys and secrets. So on this side, you might actually just push those over like username, password when you log in from an API. I would say that's okay, and that's usually how it goes, but we shouldn't do that. Because we're giving away the only secret there is. That's the access to everything, and we're sending that off in a sometimes unsecure way. So the better way of doing it would actually be to take a little access key, and then we sign that with a secret key. Okay, so we just produce something else with the secret key, and then to mix everything up, because we want to be ultra sure that this is secure, we actually add time to this. So whatever time is right now, we just concatenate that with the access key, and we sign the whole thing with the secret key, and then we send the access key and that signature to the server. In this way, we have never ever actually sent the secret key, but we send a proof that we have one. And what this time does is that it actually protects us for someone stealing that request and then replaying that later on, because it won't work anymore, because it's limited within a set period of time. So then we send that off to the server, and of course we have the same information over here. So we just do the same calculation as we do over here, and then we can validate that, and we know whoever sent this access key and that signature actually owns the secret key. And we have to do some magic with the time as well to make sure that it all fits up. But if it fits up, we can actually quite sure say that they have access to this API. And then of course, these things here are quite sensitive, and they're similar like username and password, or more like passwords. So we should treat these as passwords. So we might want to store them hashed or encrypted in some ways. We don't store them in plain text, because if this database over here leaks, or we might not know about the leak, but someone actually has access to it, they can take that plain text information and start doing this. But if we store that slightly more secure, we are avoiding that problem a little bit more. So that protects against the data leak. And this is a little summary of this slide. I'm not going to read it, but the most important thing is that we keep the secret key secret. That's why it's called secret key. That's why we don't send it. Okay. So, of course, we need to exchange this secret key somehow, usually, of different reasons. We need to agree between the server and the client that this is a secret key. And there are many different ways of doing that. One we call pre-bundled, and they can be consumer generated, and then we have this Diffie-Hellman thing down here. And they kind of become more secure further down, but they also become more complex. And they have their own negative sides as well, of course. Pre-bundle is what we call hard-coded. So we put the secret key into an app, or I've even seen HTML and JavaScript pages having secret keys in them. Again, it's called secret of a reason. So we should avoid that, but that's a very, very common solution of doing it. Consumer generated is what we call shared ones, with these small situation marks. Because they might be generated on a web page. They go in there and they generate one and they copy and paste it So they are shared once, but then they are copy and pasted and emailed and whatever they are. So it's good to try to avoid this as well, although sometimes it's the only way forward. And then we have Diffie-Hellman here, which I'm going to explain in a little bit for you who don't know what it is. But as a sort of a mathematical way of exchanging keys. And this is probably the better way, but then there's this little thing called man in the middle, which I'm going to go through in a little bit as well. So all these are ways of sharing keys, and they all have negative sides. These we could probably easily understand why they are sort of not so secure. I'm going to look at what this is. So Diffie-Hellman is quite old, from the 70s, mathematical algorithm actually calculating things from different values where both sides don't have all the values, but they can still reach the same result. I'm going to explain a little bit how it works. So we will have two users, doesn't matter who they are. And there's this little public area here, we call it the internet or something. They're going to exchange things here now. So we're going to ask both sides to pick one color together. They're going to decide on, well, this is our common publicly known color. So we just share that with the world. And then we know both of them has that. Everyone else knows that. And then they pick two secret colors that they don't share with anyone. So they keep this on their side. Whatever color they selected, they don't share it with each other and they don't share it over the internet. And then they add this public color with whatever secret color they had, and they get another color. And the same on this side. And that color they send to the other side. So now we have three colors here that are publicly known. But these two are still secret. So if they then do a final calculations on both sides, where they add this shared color from the opposite side with the secret color that they had, they get brown. And yeah, all colors turn brown if mixed. So color is a bad example, but this is basically how it works. So you get brown on both sides. But brown has never been communicated. So this is basically what Diffie-Hellman is, but it's large prime numbers we're talking about. And they have a mathematical relationship similar to this. So that works well in a controlled environment. And then we have that man in the middle thing. And if it's a passive man in the middle, I did actually get this question when I was suggesting an improvement for a key exchange just recently. Well, I said, well, we did this because it's protected against man in the middle, isn't it? I said, yeah, kind of, but there are two types. There's the passive one, which is just looking at this. And if we were just looking at this, we would know these three colors. And we can't do anything because we don't know those two. So we can't do the same calculation as they can do. So for us in the middle, we don't know the secret. But then we have the active man in the middle attack, which is where we're going to exchange. We're going to modify what they're sending. We put ourselves in the middle, receive a color, and we change it to another color and send it up here. They don't know that we changed it. All of a sudden, we have all the colors as man in the middle, and we can calculate two secrets, one from that side and another from that side. So basically, we just throw anything in there, and we just screw the whole thing. So this doesn't actually protect against active man in the middle. There are ways of doing that, but I'm not going to go into that today. But that we go into sort of a public and private key kind of solution. So let's continue with this here. Anyone heard about this? I'm sure most of you have heard of it. We actually say that we skip the 2 now because Oath 1 is deprecated, more or less. So it's Oath 2 that is sort of the standard. And this is how many of you would say, well, I'm comfortable with this is. I can implement this in a system. He had a beer, so he's quite comfortable. I can see that. It's another one, yeah. Most people don't really know what this is. I mean, you know it's something about sort of logging in or whatever, But this here is what we call a meta protocol. It just kind of describes things to do. It's not a way of actually giving people access, and it's definitely not something that would authenticate you, because there's nothing about identity in here. It's only about giving access to things. So you don't actually know who's getting access, just that they have the right to do it. So I'm gonna go slightly through how Auth2 is built and how it's actually used. So you would have a resource server somewhere. This is where you have all the data that you want someone to have access to. And you don't build anything there to hold access control. You delegate that to another server. And this could potentially be Facebook, Google, or LinkedIn, or Twitter, whatever, or something of your own. So you would just say, we're going to trust this server. So if this server says it's okay to access things here, we're okay with that. We don't care who they are. This server said that it's okay. So then we have this person down here, which is actually the resource owner. So they own something up in this server. And they want to access that through some sort of mobile client or whatever. So they go into their client and say, well, I want my resources. And what's going to happen is that they're going to have to go here to grant access to this client up here. So this here is usually done, you see, you log in with Google or something. So you get a little screen as a frame or something inside the app. And that's usually coming from that actually server. And that's part of the whole package, that it comes from that server and not from your server. And then they start sending lots of tokens. There's more than one token here. There's quite many tokens going back and forth. And they actually use a little trick with HTTP status code 302, I think it is, I think it's called permanently redirected. So they kind of use that when they respond back, which the browser would then send somewhere else. So it's quite a sort of complicated relationship, but it works quite well. So then we have a token up here that we can use to access. So we then go to this server here, and usually through our API. So we send that token over here, and when it gets here, they're actually going to have to check with this. Is this okay? This token that I got, have you granted this access? And they will say, yes, we have, and they can give back the data. But there's nothing in here saying who. It's just about access. So we don't actually know who this is. This could be someone who delegated access to someone else, but we don't know that. So one part of Auth part that isn't part of Auth is this, perhaps an identity provider over here. And this is where things like OpenID and things like that comes into place. But this is a different server, or could be the same server. Doesn't really matter, but there's a different provider where you could send whatever you got up here to some sort of endpoint that gives you back identity information. And then we are starting to get to authenticate, sorry. Very difficult to keep apart. So altogether, we actually give a quite nice way of giving access to things, but they're quite complicated. But that's the step above the one that we saw first with access key and secrets. And of course, to note is that at all these places here, and potentially over there as well, there is authentication. Here, the user has to say who they are to this server. Here, the client has to say, I'm this client, because you have to pre-register every client. You know, you create like a Facebook app or something like that your app or website talks to. That's that pre-registration being done. And of course, here is going to be an authenticate, and at the beginning here, there's an authenticate as well. So there's a lot of authentication going on in between, just to get access to something. But it works quite well. And this is actually the complicated flow. I think it's called authorization code flow, and there are simpler flows for less secure environments like web pages and stuff that can't securely hold these keys, because there's actually an access key and a secret here as well. It's called differently, but it's the same principle. Let's talk about sessions, because this is something happens afterwards. Now you actually logged in, and now you have authenticated yourself and so forth. And they usually get something called a session. So if we take our little API again, and now we just assume that we have authenticated to this. So we're okay. They know who we are from this side. And usually something is created here. It doesn't necessarily have to be this, but there's something created here. So let's assume we create some sort of session. And we could put stuff in here. I'm going to get back to the refresh token in a bit, but if we put in role in this session, all of a sudden we have authorization. Because role is more what you can do rather than who you are. We said who we are here, and now we're getting something back saying we can do this. And we can put anything in there. That's just examples. And the nice thing that we could do, again, is to sign this whole package with something secret on the back-end side. So we put stuff in there, we put the signature, and we could send that signature with the whole package to the client. Sorry. And we get a signed session token over here at the client side, which we'll then use for all other endpoints we want to access. So what does this give us? Signed session token. Any have a suggestion what will happen here? We have a signed session token with data in it. It's free access to the left side, because now we can get in here, but we do get something else for free if we do it this way. Since this is signed, we can't modify this data over here. So we just put stuff in like user ID, role, expire, whatever, and then we sign it, and we get free access here. It's plain text. We could modify it, we could edit it in any way that we like, and we can send that back. But then when we validate this signature, it's going to fail. So even if we told the clients, here's all the data that we know about you, they can't change it because we signed it. And that, in turn, creates a stateless backend. Because we gave the state away to the client. Say, well, this is your state, and now we don't care what you do with that. Come back when you feel like it. We don't have to store stuff in the database about who's logged in or anything, because we signed it. We know this is ours. So if someone hands it back to us, we can validate it's ours. Okay, it's ours. We have approved them. We don't remember it, but it looks good, so give them access. And that's perfectly secure. And then we have the refresh token that we also created here and sent back. So what the refresh token will do for us is that if this is short-lived, it has an expiry time at, I don't know, 3, 4, 24 hours, whatever. What's appropriate for our system? It should be short. Usually I see a lot of systems and they go, oh, it was too difficult because they had to log in, so we just extended the expiry date all the time, and it all ended up like 2 years expiry date. So I mean, it's, you log in, you're in there forever. So this becomes quite sensitive, because if you lose one of these and it has a 2 years expiry date, anyone can log in. Particularly if we built a stateless backend, because then we have nothing to check against, and that could be a problem if we do it incorrectly. So then we give them a short time session token, and we give them expiry token that might last for, let's say, 2 weeks, 30 days, something. But they can keep that on their side. They don't communicate it until they need another session. So we split this problem of logging into many times between these two tokens. So when they need a new one, they'll just send a refresh token to some endpoint where it says, give me a new session. And if that's a valid refresh token, we send a new signed session token back, and preferably a new refresh token as well. So in that sense, we could keep a session running for a very long time without actually putting 2 years expiry date on that one. So we have to build clients in order to solve that. Usually it's not a good idea to have that too long either in expiry date. But it can be because we're not communicating more than once. So a little summary for this slide, and really this is probably the most important thing. If you get a session token coming in, no matter how stateless your backend is, doesn't matter, validate it every single time. If it was okay up here, don't assume it's going to be okay on all the other ones following. Always validate them, because that's really where most leaks end up, is because we don't validate stuff. So let's talk about that. So again, we have an API in the middle. We have some cool service on this side, and we have our users. If you had to choose, which side would you actually trust? This side or this side? Who trusts this side? Oh, this is you had developed it, so you should trust it's your code. You changed your mind now when you knew it was your code. Anyway, who trusts this side? So no one trusts that side. So we have a few people trust this side because we know this. I mean, that's our thing. And this one, we don't know what they want. And life would be better without users, so stay away from our system. Okay, I would actually claim that we shouldn't trust either of these sides. Okay, we wrote this, so yeah, we probably have a little bit more trust in this. But the problem is that we wrote this, so we shouldn't trust it. And those we should never trust. And why is that? Well, we're sending a lot of data, or users are sending a lot of data to our database or whatever it is, and then they're getting data coming out and going back to them. That's called a service. So there'll be all these kind of data depending on what we're looking at. And maybe we implement something that will get some username coming in. We need to check for stuff. We might want to check for if they're actually putting in SQL statements, for example, trying to do something funny. And that is actually the same when coming out. Because you could actually push things in here that will just lay in wait for the next user to access them on your profile page, for example. So they will fetch this data coming back again, and then something will happen because they stored something there that wasn't supposed to be there. Or even easier, some HTML or some JavaScript. So what we need to do is when we get data coming in, we validate it, and we do that there. Not there, we do that there, as soon as possible. Is this within range? Is this okay? We could do that in many different ways. Easiest way is usually to whitelist things, because we'll just okay the good stuff that we know is good, and everything else is bad. Actually, I spoke to a guy who used to work for Panda Security, I think, and when Pattaya hit in Spain, like 1 year ago, something like that, there was this company, they have like 30,000 computers, and half of them were running Panda Security, and half of them were running Semantic Security in one way or another. And the Semantic computers, they all crashed. Whereas the Panda securities, they actually managed to contain this ransomware attack. And why? Because the Panda was using whitelisting, whereas Semantic was using blacklisting. So Pattaya, which was completely new, Semantic knew nothing about, whereas Panda didn't either know about it, but they just know that we haven't actually agreed to run that code before, so we're not going to do it now either. So whitelisting is always better. But this could be regex, that could be if statements compared to whatever, and so forth. But it needs to be done at the endpoint. And the same, actually, when we're sending it out, now this arrow should probably be there, because when we take stuff out from a database, we encode it directly to make sure it's okay. And when we encode stuff, we are removing HTML, we're removing code, we're removing SQL statement and so forth. Because we say, this is plain text. You don't do anything with it, it's plain text. If we don't do that, and we are like 20 developers on this way here, we don't know what's going to happen. So the person that writes the stuff next to the database encode it, whereas the person who writes the code just by the endpoint validate it. And then it's not so bad to validate it a couple more times before it hits the database. And the funny thing is that one of the big reasons why you couldn't trust this side is because you have admin and support people. And they're users on your database as well. They're not those users because they get paid to take care of this. And there's no reason to say, well, since they work for us, they're actually going to be trustworthy. And they might not do anything intentionally. They could create stuff unintentionally because they have direct access to the database. They can go in and change that code if they like. So we don't trust either side. And a little summary, and of course, as early as possible, you validate and encode your data. Some small additional ingredients. I'm not going to go through them, but I might have touched on some of them, or maybe I should go through them. Grids. Why should we use grids instead of indexes when we have like user IDs and things like that? Anyone have a good? You can't guess them. That's exactly. They are not encoded. They're not encrypted. They're not secret, but they don't follow in sequence. So if you have a user ID of 15, you could probably guess there's going to be a user ID of 14 as well. And then you're going to say, well, there's going to be a user ID of 0, 1, and that's going to be the admin. If you use grids instead, you can't guess them. And computers don't care, so use them. You rather want to use rate limitation rather than locking someone's account when they try to log in too many times. Why is that? Anyone knows? Exactly. Because if you're locking someone's account because they tried three times or 10 times or whatever, you're actually opening up for denial of service. So if I could iterate over a company's email addresses trying to guess usernames, I could probably lock them all out from their systems. So that's why you use rate limitation. So the following request after an unsuccessful request will take a little bit longer to respond to. And that will pick up, and after a while, after maybe 500 requests or whatever it is, it'll take like 15, 20, an hour for the server to respond, which makes brute force kind of useless because it takes too long. Whitelisting rather than blacklisting, we talked about that. And of course, we need to log every single event that happens. We get inside an endpoint, we log it. And if there is an error, we log that. Because then we build monitoring system on top of that. We know what's going on in the system. So we need to log everything. It's always a good idea to write unit tests. How many unit tests have you written today? 1? A few? Anyone else written some unit tests today? There's a couple. There's 2 at least. Good. Unit tests are really good, and that's something we don't really do because I don't know, we don't like doing it as developers, but they are actually good because they can catch problems. We all know this. But particularly for endpoints and APIs, so we'll test the endpoints, and what happens is that we test the entire system behind it. So we send stuff in, it's going to go through the database, and it's going to come back, and whatever it is, and we'll test the whole thing. So it's a quite nice sort of starting point for unit tests. And they will help with security as well to find what might not work if we write the correct unit test, of course. If you do make an API, we need to document it. Who spent half of this day writing documentation for the code they write?
Or just documentation.
Or just documentation, yeah. Anyone else that's been very good today? There's one more. We don't generally write documentation. Why should we? Code should read for itself. Am I right? But we're talking about APIs now. We're talking about someone gonna use your API from the outside, not gonna read your code. They're just gonna get a bunch of endcodes. We need documentation. Valid per. Exactly. If you don't do this correctly, someone like this lady here will just come and smack you in the face, and you do it again, do it right. So we need to do that, and we need to put what's the valid parameters, what's the invalid parameters, and whatever it is. And the nice thing is actually to include some code snippets. This is how you should use it. This is how you sign your secret or your access key with a secret key. Because then we're giving away, this is how you should use it. So, because we're going to trust those integrations. So they're not doing the wrong thing as well. So if we can help them a little bit, then that's always good. And I haven't actually said this, but this is like, that's a sin if you're not using HTTPS. Everyone should be doing that. Anyone using an API right now that's over HTTP that you know about? No, it shouldn't be. That's standard. Anything else should probably be changed. And this we talked about. We should never ever trust input from the user. We need to validate it and assume they're trying to do bad things. I have a little extra bit. It's not very long, but this is when APIs they grow up and become big, and they're gonna serve many systems in a very complex environment. There is actually something of a stack that someone has made up. It's called the Neo Security Stack, and it consists of all these different areas. So this is when you build APIs to serve enterprises. And on top we have authentication. Then we have systems like OpenID Connect and FIDO. OpenID Connect is built on Auth2. To provide identity, among other things. FIDO, anyone heard about that? It's got web authentication, maybe you heard about. That's when you have like a two-factor hardware thing connected to your browser, and then your web pages or your web services can log in through that. It's becoming a standard within browsers now. So for anyone that's familiar with JavaScript, that's probably something to look at. Provisioning. This is something I can't remember what it's called. It's a standard from actually sending out and removing users from different systems. So it's just how you would propagate a user through a system. And then we have something that we all should learn about, which is identities. It's the JSON Identity Suite. Anyone knows about this? Have you heard about JWT? Is part of this. It's actually called JOT, JWT. That's how you pronounce it, JOT, of some inexplicable reason, I don't know. But this has many different JSON objects that are defined for sending sessions, sending encryption keys, and whatever it is. So that's a good one to look into, because this is becoming a standard of actually sending data over JSON. Federation, this is about controlling lots of systems and giving them power to do their own thing and keeping it all together. And again, we have OpenID, and then we have SAML. SAML tokens is an awful thing written in XML. It's just very talkative and a bit annoying to use. These two don't talk too well together, so you don't generally mix them two. Delegated access, there we have Oath. So this is about delegating. I mean, I give you access to my Facebook account or whatever it is. That's delegating access. So that's what I used for. And finally, we have a small language down here, which is just describing how authorization works within this whole thing. So there's these two, and I think Alpha is actually compatible with XACML. This is just a JSON-like thing, and this is XML. So easier to use, but same thing. So you just describe access within a system, really. That's pretty much it. But